Hello dear students, this time we will talk about the entropy, a subject that is part of the course thermodynamics. The group is formed by
Castillo Peralta Ana Isabel. Cienfuegos Caro Diana Carolina. Esquivel Paredes Darly Damaris. Paredes Eche Marjorie Garnier. Requejo Fernández Brenda Lisbeth.
Now, we will start with the objectives. The objective number 1. Define the property called entropy to quantify the effects of the second law. The objective number 2. Establish the principle of entropy increase. And the objective number 3. Calculate entropy changes that occur during processes for pure substances. Generally, entropy is the degree of disorder that a system has. Entropy changes the state of an object significantly. When a material contains little entropy, it is perceived as cold. If the same material contains more and even more entropy, it can be perceived as warm or even hot respectively. Second law of thermodynamics. This law regulates the direction in which thermodynamic processes must be carried out and, therefore, the impossibility of occurring in the opposite direction. The first law denies the possibility of creating or destroying energy, the second limits the availability of energy and the ways in which it can be used and converted. It is the physical quantity that measures the part of the energy that cannot be used to produce work. It is a quantitative measure of disorder. It is a state function of extensive character, and its value, in an isolated system, grows in the course of a process that occurs naturally. Entropy describes the irreversibility of thermodynamic systems. The characteristics that it presents are the following. Entropy tends to spread. In a homogeneous body, the entropy is distributed automatically more or less quickly and uniformly throughout the volume. Entropy occurs easily. The most striking feature of entropy is the following. Although entropy occurs in virtually all processes in either small or large quantities, no mechanism is known by which, once the amount of entropy has occurred, can be destroyed. Well, now we will talk about the inequality of Clausius. The equation is conformed by, the integral with a circle is called closed integral, and it means that the sum is effected on a curve that closes on itself. It represents the amount of differential heat that enters the system from a focus at the temperature T. Throughout a cycle there will be times when its value is positive and times when it will be negative, as the system absorbs or yields heat. It is the temperature of the focus that yields the heat. Emphasizing the following topic, we can say that, in any reversible process, the entropy of the universe remains constant. In every irreversible process, the entropy of the universe increases. Reversible and irreversible processes. Reversible processes. It is defined as a process that can be reversed without leaving a trace to the surroundings, that is, both the system and the surroundings return to their initial states, once the reverse process is completed. Only this is possible if the net heat and work exchange between systems and surroundings is zero for the combined process. Carnot cycle. Adiabatic transformation. An adiabatic transformation is characterized in that the working substance does not exchange heat, is that, the heat differential is equal to zero, where entropy differential is equal between the derivation of heat and temperature. The increase in entropy is equal to the integral of 1 to 2 of the differential equals entropy 2 minus entropy 1, and this is 0. It follows then that between two states 1 and 2 joined by a reversible adiabatic transformation, the entropy does not change, so these transformations are also called isentropic. Isothermal transformation. Taking into account that the temperature is constant, we can take it out of the integral in the calculation of the entropy variation. The entropy variation is equal to the integral of 1 to 2 of the heat differential over the temperature, and this is equal to 1 over the temperature by the integral of 1 to 2 of the heat differential, and we have as a result heat absorbed over the temperature. This expression is used to calculate the entropy change of a heat source, A device capable of absorbing or yielding heat without changing its temperature. Making use of the expression given by the heat exchanged in an isothermal transformation experienced by an ideal gas. The entropy variation of 1 to 2 is equal to heat over temperature, and this is equal to in number of moles. R is constant of the gaseous by the natural logarithm of volume 2 between volume 1. Isochronous transformation. An isochronous transformation is one in which the volume remains constant. Using the expression that gives the heat exchanging in an isochronous transformation, we get, the increase in entropy is equal to the integral of 1 to 2 of the heat differential between temperature, and this gives the final result to N as number of moles for the constant and for the natural logarithm of temperature 2 between temperature 1. Isochronous transformation. To compute the change in entropy in an isoform transformation, a procedure analogous to the above is followed. The only difference is that the heat capacity for this transformation is the heat capacity at constant pressure of an ideal gas. The difference between the other transformations is that in the isobar its constant is the pressure, and we fear that the increase of the entropy is equal to the number of moles for the constant and the multiplication of the temperature 2 over the temperature 1. As can be seen, in the last two transformations an increase in temperature leads to an increase in entropy. Irreversible process. Irreversibility, or moving away from the ideal condition of reversibility, reflects an increase in the amount of unorganized energy at the expense of better organized energy. Organized energy, such as a raised weight, is easily put into practical use. Disorganized energy, such as random motions of molecules in a gas, requires force or restraint before it can be used effectively. The engineer constantly strives to reduce the irreversibility of the systems to obtain a better functioning of the systems. Example: a thermal machine that works between two thermal bulbs at 100 K and 500 K, absorbs in each cycle 1000 J of heat from the hot bulb. If your performance is 20%, answer the following questions. Does the machine work reversibly or irreversibly? The performance of a Carnot machine working in a system between the same sources is greater than the machine. It means that it works irreversibly. Principle of entropy increment. It is considered a cycle that consists of two processes, process 1-2 that is arbitrary, reversible or irreversible, and 2-1 that is internally reversible. The quantity variation of S equal S2 less S1, represents the entropy change of the system for a reversible process. The principle of increasing entropy. The entropy of an isolated system during a process always increases, or in the limit case of a reversible process remains constant, that is to say it never decreases. Then the total entropy is equal to the sum of the entropy of the parts of the system, that is, a system and its surroundings. In conclusion, the total entropy is greater than 0 if the process is irreversible, is equal to 0 if it is reversible, and if the entropy is equal to 0 the process is impossible. Change of entropy of pure substances. The entropy values in the property tables are offered with respect to an arbitrary reference state. In the water vapor tables, the entropy of saturated liquids at 0.01 degrees Celsius is assigned the value of 0, and for refrigerant 134, the 0 value is assigned to the saturated liquid at 40 degrees Celsius. Entropy values become negative at temperatures below the reference value. The general characteristics of the TS diagram for pure substances is shown in the figure, in which data for water are used. In this diagram, the lines of constant volume are precipitated more than those of constant pressure, which in turn are parallel to those of constant temperature in the humid vapor region. Also, the constant pressure lines almost coincide. Our conclusions are: the Clausius inequality is a formulation of the second principle that allows to define the state function of entropy. The principle of entropy increase states that the entropy of the system plus that of the environment, total or universe entropy, must increase in an irreversible process and remain constant in a reversible process. The entropy of a pure substance is determined by the tables with respect to their reference state. Thank you so much for watching this video.